Hi, everyone. This is episode 50. Hi, Harry. Hi, Rob. How are you guys doing?
Doing great.
All right,
I'm
awesome.
great,
Thanks
very
for
good. How are you?
good. Thanks for being here. I actually traveled up north. I'm in Cleveland today. Just found a conference room here to chill. So we got a bunch of exciting stories here. We're going to talk about a special font that's going to help websites save their data. This I thought was fascinating and interesting to protect your sort of intellectual property from AI scrapers. Then we have obviously topics around agentic commerce. We're going to kick off with that, and then what Cursor is cooking, right? An alternative way to sort of think about Git in the future of AI, where with multiple AI agents. I mean, GitHub is obviously having lots of scalability issues recently. I thought that blog was fascinating to cover that. And also this whole push of getting agents off your laptop and running in the cloud, that will be another group of stories we're going to do that. With that said, let's switch gear and talk about Stripe. I thought that was very unusual. I was not honestly expecting that, but I feel like some of you were expecting this. So Stripe buying OpenRouter. So do you guys use OpenRouter at all?
We do. Yeah.
I kind of do. I think I was at one point using it for getting my models, like as an. I mean, there are two I use, right? One is OpenCode Go. I was just experimenting with models because it's cheap, right? $5 a month. When you start off and $10 afterwards, it's like the cheapest way to get access to models. And then Stripe, I think, your OpenRouter itself, just to experiment with it. But some of those models are quantized. So at that point, I stopped looking into it. I think after that, I've been stuck with OpenCode for the longest of time. But I kept at it to see like what this model routers are generally going at and what's the interest in it. And this came as quite a, while kind of expected, it's also very surprising. Like at the valuation at which it has been acquired, also, right? Somewhere north of 9 billion. And the valuation it was earlier during this year was 2.5, right? And that itself was like,
You're
okay,
saying
open
9
router at
billion, right? I just want to make sure
yeah,
we heard right. Okay, yeah.
yeah. It's kind of, and imagine like
I
that
mean, the
kind of,
stats are pretty impressive, though, right? I mean, no wonder they got this valuation. I mean,
of course,
everybody uses this. How they manage this Open AI standard API interface, so it doesn't matter which model you invoke to?
yeah.
Yeah.
I mean, sorry, go ahead, Rob.
Yeah. No, like it's so that you can connect once and then switch out the models and be able to pass it along. It makes it 10 times easier. You don't have to rewrite your code.
So Stripe being a payment provider, why Stripe is interested in this? Is that weird, or am I missing something?
I've heard that OpenRouter is the Stripe of tokens. So it's an intermediary between like the actual spending of the tokens. And
yeah, tokens are your new dollars, huh?
it gives you, like OpenRouter itself gives you an insight into like what models people are using. It gives you that higher level visibility on like how models are being used, what's popular, what's not.
So it's
And
almost
Stripe does. Yeah, sorry, go ahead.
Sorry, I think I was just going to add, it's almost like intelligence on hire, right? And this is like the first marketplace I'm thinking. I don't know when this will come to like actual reality. Like just imagine this, right? You have a frontier model doing some work, and then you want to get some cheaper work done, and then your harness, like, on the fly decides that, hey, I want to pick like Quen or something like that, and then I want to get some work done from it, and I'll pay as I go right there. I'll agent to agent payment happens, and then I just settle that job. Technically speaking, it's almost like gig work happening between agents, where agents are farming out work to other agents. That's like the big, like, eventual agentic society, if you will. Like there'll be commerce within that agentic society, right? And I guess Stripe wants to be the one which brokers the commerce there.
Now this fits perfectly well with their business, right? I mean, they want to be the payment gateway. They are the payment gateway for internet, right? They want to be the payment gateway for this agentic commerce. In that sense, router is that sort of a gateway. So in that way, it makes sense.
And it also is a sense of. Sorry, go ahead, please. Yeah.
No.
again, this is just my thinking, right? Like it's almost like software itself becomes a little fungible in the sense that you don't have like permanent services, I guess. So you have like custom service to be built on a fly or something like that. So that unit of work becomes a lot more like cheaper. Just I could build something very custom for that use case, get that script built, throw it away, sell it, and then buy it. And yeah, it just becomes very, very arbitrage driven.
Yeah. And we talked about this I think in the previous podcast too. Isn't that Cloudflare building something over, I don't know, it's not teapot protocol, something they were using you can make HTTP request to get a page that's behind the paywall. So through HTTP, you make a sort of a transaction to get the data. And I totally see, Harry, you there?
There's an HTTP status code for payments. I think that's what.
Guys, you there?
Oh,
yeah.
Sorry. Okay. Yes. I was just connecting the dots here. In last podcast, we talked about like Cloudflare doing something over HTTP where you can pay for page requests, right? Classically fits well with the agent. If agent has a Stripe account, quote unquote, then agent could sort of make that transaction, get a page behind the paywall, get the data to do some processing. So all this sort of fits into that model very well.
Yeah, in that case, they were using the payment status code to tell the agent that you need to pay to get this, and then that's actually the next step is having Stripe or something where they can actually pay and do the transaction and then get access to it.
Would you guys feel comfortable doing that? Give your agents some wallet with some dollars to go crazy.
Oh, I see Harry saying yes. Okay.
Yeah,
this is good.
I think in due course it's going to happen, right? I need to give it a wallet. I need to give it some money, and have it do the job, right? Like, of course, I want it's like this, right? Even now, I'm giving my agent, again, this is my thinking. Even now, I'm giving my agent money by means of resources like electricity and all of that. It's like it's using that to do something, and I'm giving it that budget. So money is just another way of like giving it that budget to do something. As long as it's able to perform, why not? Is what I'm thinking.
That's interesting. It's like you have kids who are doing chores and you give them an allowance, and
something
they
like
can
that.
do whatever they want with it.
As long as you have a ceiling. It's going to be crazy.
And then eventually they make their own money and build their own bank account up, but you seed it.
That's
that's much better. I like that. I mean, that could be this whole loop thing. I know we were talking. Maybe we'll do it in podcast. So I mean, theoretically we can design this sort of loop in saying, here's a $10. Your goal is to make $100. You don't stop till you make 100. Could be. I know it's a vague target, but okay. So story.
How many tokens does it take?
I mean, think about it, right? You integrate MailChimp, for example, with an agent, and you say, hey, go do cold sales with all this database of contacts, generate leads, get me something. That MailChimp mail token is also money. I mean, so it's the only thing we have not yet given the agent is actual money to like go spend by itself, but that's not too far away. And why I was kind of interested is there was this two competing protocols, so to speak, right? Universal Commerce Protocol, UCP, which is like the Google backed thing, Tech Council thing. And then there's the ACP, which is the Agentic Commerce Protocol, which was the Stripe-backed thing. Both of them are architecturally a little interesting. I haven't really gone into the depth of it. But again, it'll be interesting to see which ecosystem is thriving, and that also might give us an idea of what to expect. I think the question is very important, like the way you put it, Neil. Would you give it money? How that money is given and how that money is spent and how it's accounted for, that will be some way connected to how the protocol is designed in terms of what can be possible. So anyway, I'll stop there. So UCP and ACP are something to watch out for in the context of this particular thing.
I mean, it's also one thing we have to remember: whoever has a bigger market cap will win. It's necessarily not the best protocol, right? I mean, Stripe getting into, I mean, I know it's Google. Google has all the power. but getting into Open Router, I mean, I would expect to see some interesting thing happening out of that. Maybe it makes it super easy for anyone
Yeah.
use
In
agentic
fact,
commerce from
Stripe,
that.
if you think about it, is a very dev-friendly payment gateway. If you think about it, it was always CLI, it was always APIs versus like the others. And I think
Wall
someone
standard
made a,
documentations,
yeah,
right?
and it's for developers largely, right?
Yeah.
And think about it. Suddenly, Stripe is the most favorite integration platform for agents because agents love that documentation because agents are writing code for it. So I think I think this is what someone else said. I don't know which podcast is it. Like I listen to a lot of them. So someone made this observation and that made a lot of sense. That yeah, I mean if it's dev friendly, it's agent friendly. So that's probably it.
Very good point. Speaking of this Stripe buying Open Router, there is one big news. I caught this today morning, so that's why it's not in our show notes, which is NVIDIA buying Hugging Face for 12.9 billion. To be honest with you, 12.9 billion in this whole context seems smaller to me because Hugging Face has so much contribution to the industry. But again, a question for you guys: why is NVIDIA buying Hugging? First of all, I have no. Maybe you have to educate me. I don't know how they made money or how they are making money. Do you guys know how they make money? Because everything seems free there.
Yeah, it has to do with the accounts and hosting. Their revenue, I think, is a lot less than what they just got acquired for. It's like maybe 200 million in revenue.
Okay.
So this is like, it's a good multiple. It's actually twice what NVIDIA offered them a few months ago, back in January, I think. It was around 7 billion or something.
Oh, interesting. So what changed between January and now?
I think it's NVIDIA's strategy. They are becoming the home for open models. So like this is just part of that thesis and acquisitions because it's where all open models are hosted. So now they have control of it. They're pushing open models. It sells more hardware, sells it to consumers as well as not just businesses and data centers. So it does expand their market.
Yeah, I mean, another thing, I think you're absolutely right, Rob, that, I mean, this is a sign that NVIDIA also thinks that open models have a really strong future. I mean, it goes both ways though, right? If more open model gets popular, I mean, more of folks like you and me going to buy their hardware to host them.
Yep. They support a lot of local AI stuff, creators. They train their own models. The Nematron Parakeet is actually really good for voice to text. That's what I use locally, and it's super lightweight. But yeah, they're super into local models, and this is just another part of that play.
Yeah, super cool. I mean, I think, needless to say, Hugging Face has tremendous contribution to this space. I mean, lots of open source models, and it's a lovely hosting place. Like, you're right, they probably make money through hosting. I never paid money to them, but I'm pretty sure use their services a lot. So NVIDIA buying them and supporting them. I know lots of other companies is to give them compute to run the models or host the models. Well, this would be I feel like overall, this would be great for the open model community and for all of us.
Yeah, hosting the benchmarks as well. Obviously, that's why they were attacked, was because OpenAI's agent was trying to cheat on the test by finding the answers. That's why they hacked Hugging Face, but that's like another revenue angle thing that they do.
Yeah. So I want to switch gear a little bit here. I know before going live, Harry was talking about Herdr and Orb. There are lots of other interesting stuff coming out here, which allows us to off your agent from your local machine to remote cloud systems and run it for long running processes, I'm assuming. So Harry, you want to walk us through what's going on in that space?
Yeah, let me just share my screen. And I think last podcast we had, I hope my screen's visible.
Yeah.
All right. Last podcast, I think we had Rob show CMux, right? And it's one of those ways of like CMux basically being this guy, which is, yeah, you can have your workspaces and, configure like what's going on and stuff like that. Now, Herdr is something that I've been experimenting with primarily because there is that aspect of running one server to which is detached, and then I can submit my jobs, and it's a agent multiplexer at its core, right? Which means, for example, I just have a terminal UI based interface to Herdr. This largely is the overall structure of it. On the left, you will see the workspaces.
So dumb it down for me. So if I, why would I use it? So let's say I have a couple of agents I want to run.
So for example, I use open code, right, on one side, which is one agent harness, and then I use Codex, which is my other agent harness. Now, both of which are actively running. One problem I often face, okay, why do I do this in the first place? That's another thing, right? The reason being, sometimes even within the same project, I use different harnesses because some harnesses have affinity to models and stuff like that. So I tend to have like multiple harnesses running within the same project. Now, when I have multiple harnesses running, each of this might be waiting for an input from me, or like I have like something to give it back or answer questions and stuff like that, and I might switch to doing something else in between and I forget. And most of the time what I realize, the most annoying thing is you realize that that fellow was waiting for you all this while, and you were just like thinking that it's working off in the background. And that's the one which even Rob highlighted.
We are the bottleneck this does, isn't it?
We are the bottleneck, yeah. So for example, I'll just show you like what it happens, right? Like I'll typically just like put it in plan mode, and I'll give it a task just for demonstration purposes. Let open code go on with the GLM 5.3, and I have Codex and say, give it some other task, explore, no duplicate words, something like that, right? And so these guys are happily running off, and you can see that on the left hand side. Meanwhile, I might want to inspect my configuration. So I just click on it and I'm in a separate window. I'm reading through Markdown or reading through code, and something's happening. These fellows are happily working off. Here I can keep an eye on them. And whenever they are done, there will be like what happens is the architecture here is very straightforward, at least as far as I understand. Open code has a plugin for Herdr, and or rather Herdr has a plugin for open code where Herdr listens to the status of open code, whether the agent is actively running, it's idling, it's waiting, or something like that. And whenever that it understands that status after polling or whatever it is doing, then based on that, it's going to give me a ping saying, hey, he's waiting on an input, and it chimes. So I know that's going to happen, and I go and look at it. That's the most ground zero reason why you will use Herdr. I hope I answered your question, right, Neil? The bigger point is, this is a detached screen. This is just a terminal, which is a client to the overall server which Herdr is running. I could kill this terminal. I could come back.
Yeah, just to be fair, the agent is running, the code actually running remotely somewhere, right?
No, I mean, right now Herdr is running. The server is also running on my laptop.
Okay.
But technically speaking, you are right. You could run it anywhere else if you wanted to. It really doesn't matter. I could just leave it here, and my, just step away, and even if it goes to sleep, I can come back, I can resume all of that taken care of. And the next thing is, if I don't run it on my local, like what you suggested, I could push it to offload it to the cloud, and I only have the terminal interface, which is on my local machine. And I could connect it from my desktop, or maybe I have my phone from which I connect it later. So I carry it along. The bulk of the workload is happening elsewhere, and then I do it here. So basically, the reason why I just call this out is like, because you have the situation, I can like go back and like these things will be done, and I'll know what's going on. And this is typically just two agents running here, right? Imagine I have multiple workspaces here, and each workspace has like several agents running. Then that noise over the day it can be a cacophony. So after that, just trying this, I don't know if you are gamers. I used to play a lot of Age of Empires. So for me as a kid, an idle villager is the analogy that I can think of, right? All agents which are idling, I need to go find what work I can give for him, or go and do that. So that's how I look at it. So that's my naive way of, so that's the chime. So this guy is done. He's waiting for my input. So it's asking for input. So I have to answer some questions here. So I have to do all of that work. So that's what's happening. The next important thing about Herdr is that it's not perfect. Okay, I mean the terminal interface breaks often. The second thing I am not very sure I like about it is it's configuration free. It stores the workspace somewhere, like, and in the home folder. So I personally prefer version controlling my workspace so that I can just take it to another place and start off from there. But here it's almost like I gotta dump the configuration and take it. I don't know why it's like that. Maybe it's just my lack of understanding of the philosophy, but that's something that I'm struggling with right now. But that said, it's extremely lightweight, it's very fast, and unlike CMux, which is largely Mac, Herdr is a lot more pervasive. And I think it's an active community right now in terms of the plugins. So, for example, this whole thing on the left hand side, you see this Explorer view. That's not standard Herdr. That's a plugin someone has kindly, contributed to the marketplace. So that's where I'm at. I mean, the reason why I brought this up is all of us are going to be using multiple agents, multiple things, and from that point of view you need this, and also long running situations, right? For example, I think we'll talk about dynamic workflows later, Claude itself. Like, there'll be work that you step away from, and be it Herdr or even Claude itself, like building interfaces such as these to figure out what's going on, is generally the pattern of work, which is you're not going to be tied to your your keyboard and stuff. You're probably going to be on the move, and you got to keep handing work to this machine. Anyway, I'll stop there.
I actually needed this. So I drove a couple of hours to Cleveland, 2 hours, right? I was very tempted to keep my laptop open, so the agent's running while I drive. So I definitely needed something like this. Is the remote thing free or you pay for it, right? How is this?
It's all free. Yeah, you can run it wherever you want. You can connect to it. It's all up to you.
Just pay for the
it's open
compute
source
or whatever.
Yeah, just pay for the compute. Yeah, then it's good. I mean, it notifies you somehow. So do you have to be sitting in front of your, is that has a mobile connection or something? Can you operate this from your phone or something?
I haven't tried. Yeah, sorry, go ahead, Rob. I haven't tried the mobile thing on Herdr yet, but yeah, there are a lot of marketplace plugins, including an Apple Watch based mechanism where you can just click buttons and move
so mobile
with it.
Yeah, mobile integration has changed my life, man. I swear.
Yeah.
I mean, it's my
favorite interface, I think. And I don't think we don't have to take my word for it. I guess Boris Chani himself says his way of writing code is largely his mobile interface, where he keeps handing off work. So I think at one point I used to envy people who had large monitors and extensive setups and all of that. But now it's probably okay, I just have a really good phone and
that's a really good observation. That's so true. Oh, I have 3 monitors, 5 monitors.
Termius on your phone to SSH in.
Yeah.
So Rob, you've been talking about prime agents and Orb. Is it similar to this?
There's overlap in functionality. So to me, AMP code makes orbs. I don't know if anyone remembers that CLI AMP. It was probably a year ago when they said everything's going to change. You can continue to use AMP code, but we are going to completely start from scratch. And orbs are what came out of that, and they're essentially runtime sandbox environments, whatever you want to call them, with AI on top. So you interact.
Am I in the right website?
Yeah, that's the blog post explaining it.
Okay,
Okay, yeah. But yeah, they've always been use the best model. The harness fits the model. And I've been playing with it. I really like it because it does solve that problem of being able to shut your laptop and get it off. But also, you can do everything you would do locally. So you have access to a terminal. You can ask it to open a portal. So it will, if you're working on a web page, it will stand it up for you so that you have an externally available URL that you can test it. It's built in to verify whatever you're building to make sure that it works and aligns with what you asked it to do. You don't have to tell it to verify things. And it will just go open a pull request for you And so it automates a lot. It's a lot of things that I wanted it to do automatically is doing. So it is more expensive though. If you have a codex plan, you can use that as well, which makes it better. The orbs themselves are not expensive. It's because you're using the model that they select that it's slightly more expensive. Like you're paying more API rates, but if you have a codex,
wait. So when
like
you okay. So let me understand.
Orbs is the environment, but you still have to like pay for tokens.
Yeah. Okay. So yeah, it can use ChatGPT subscriptions, which is great. But if I have a Claude Max, Anthropic's Max plan,
they don't let you. Yeah, it's Anthropic that won't let you do
they
that.
won't let me. That means I have to pay like an API cost.
Yeah. So I think I have like an $8 X Grok subscription that I hooked up, and I don't know, it didn't really use that. So I'm in the process of switching over to Codex for my personal plan and getting rid of Anthropic. But I still have a whole month of Anthropic yet. So I'm like in that process because I want to go full time using orbs. And you had mentioned Prime Agent as well. That solves a similar problem for me. It's like Claude Code. It's another CLI agent harness with RLM built in, and it actually learns on the tasks. So Arc AGI 3, it performed better than any other harness. Basically because it learned the task.
So you're saying finally it will remember my stuff. It will never forget.
I don't know about that, but if you know how recursive language models work, it's like the context always exists outside of the LLM, and it could be larger than your context window. It could be the whole world, but it uses essentially what people call code mode, or writing code to explore the context and never put the full context into the model. You allow it to explore. It can call another instance of itself to recursively do the same thing, evaluate the context. So you could recursively explore the whole space with one agent at a time, but there's efficiencies. There's better efficiencies to it. But the reason I like it is I've actually been using it with my local GPUs. So when I SSH in, it has a client server model. I don't know if it's same or similar to OpenCode, Harry, because they're client server as well. But when I start a task and my SSH session dies, I can come back and pick it up because it's running. It continues to run in the background and not in my current SSH session. So that was one thing I really liked because I'm always SSHing into my GPU box. And I have benchmarks running right now since this weekend.
So I can potentially sort of stop using Claude Code and move to this.
Yeah, and I have this hooked up to use my GPUs as a custom model provider as well. So I had to like reserve 2 slots for the benchmark testing and 1 slot so I could still use Prime Agent to chat with it. Eventually I went to just using Claude Code so I could make the benchmark go faster and used all 3 slots for the benchmark, but I've just been using it with the GPUs directly as the chat model with Prime Agent. But you can use Anthropic, OpenAI, whatever, all the models.
Yeah, so if anyone interested in the call to try it out, this is open source project. You can obviously clone and, like Rob said, connect to whatever model you fancy.
I think RLMs are the future, so that's why this, Harry
have a quick
mentioned dynamic workflows.
Take 30 seconds and explain RLM again for audience here.
Yeah, so recursive language models. It came out of the Stanford lab. DSPy is another thing that came out of there. JEPA, recursive language models as well. But the idea is you can operate over essentially an infinite context by giving the agent a REPL where it can write code. And one of the things it can also do is call itself. So You have an agent that can explore the context without loading the whole context in. And that all happens outside of the agent, and it just writes code so that it can understand it, and you just let it go wild and answer whatever question that you've asked it. But this is the next thing that the models are starting to do and will be able to do, is write code for themselves, and it actually makes them smarter. The same author also came up with the what was it? The underutilized genius hypothesis? Is that what it was? I have to look at my notes. Mismanaged geniuses hypothesis.
Yeah.
So basically, every large task can be broken down into smaller tasks, and most models can do those smaller tasks, and that's actually how you get to an out of distribution result. So something that it's not trained on would be out of distribution. Something that it is would be in distribution. So if you use a harness to break these tasks down and to decompose them into different tasks, smaller tasks that it actually can do, that gets you to something that the model alone wouldn't be able to do by just asking it to do it. So that's this hypothesis, is that there is, through composition, decomposition, that these models can actually perform better than you think they can, just because we're mismanaging them. I think the speculative. So he just also did speculative programmatic tool calling.
What is that?
So the idea came from speculative execution and the speculative decoding with LLMs. Essentially, as the code is generating, you make the tool calls like as soon as they're generated in parallel before the generation finishes, because a lot of the tool calls, like a search, adds latency to it.
Right.
So the sooner you can call them, the sooner that you can run them in parallel, the faster you will get the response. And you can put a judge on it to decide which ones were relevant and throw out the rest. And so it's this speculative tool calling that it's doing. I think it's interesting because the speculative for LLM, speculative decoding, is a similar concept where there are tasks that you ask the big model, and it can be decomposed into smaller pieces. As part of that, there's a smaller task that a small model could do, and that's what that speculative decoding is like. The smaller model is providing tokens for that task that it knows how to do, and then the bigger model decides whether those are actually valid tokens. And so that's why you get that speed up in tokens per second, because you have the smaller model doing a task that it can do, but the bigger model decides whether it's relevant. So this tool calling is the same thing, where it's trying to call the tools as soon as they've been generated, before the generation finishes, and then get them judged. And at the end, you're able to like have the answer without waiting for all the tool calls. So they're not serialized anymore and waiting for the generation to finish. Because generation also can add latency. Like it can take a while to finish that generation.
Generation is the slowest bit, right? Because it's sequential.
I mean, sometimes it depends on. Some tool calls are actually slow, depending on what you're doing. So
yeah. I just make sure those tool calls are not using Stripe to send money. Otherwise, it's going to become very expensive.
That's a whole different thing we can talk about. Is how do you validate an action, a tool call, before you actually call it? That's something I'm also interested in working on.
So lots of interesting stuff happening. I mean, where are you guys getting time to do all this? This is fascinating. I love this. So this space is evolving. So I feel like engineering, programming has gone back being more interesting again, isn't it? There was like the down phase, beginning of the end of the last year, like engineers are all dying, and it's back into, I feel like you guys are having fun again. I'm having lots of fun, right?
There is so much that I want to do and try. I don't have time, and I have to focus.
Totally. That's a good problem.
Exactly.
All right, so I'm going to switch gears a little bit and talk about something which I thought kind of hilarious and funny, but maybe worth it. So this is a short, funny story about Web's newest open. So context. Context is obviously there are lots of scrapers out there, and lots of companies want to protect their data, rightly so, right? I mean, LinkedIn, open table reservation system. I could think of hundreds of companies who would not like AI agent poking in and scraping data. So I don't know how real this is, but this looks fascinating to me. There's this new font called. First of all, I don't know how font system work. I mean, this article made me think maybe I should design my own font. But there is a new font called ShieldFont. What it does is that on HTML, it will write garbage. So when an AI comes in and it's kind of scraping the markdown HTML data, it's going to get a scrap words that makes no sense. And he had a bunch of hilarious examples in here also. But when you actually render this, this is a good one here. Every morning the winners gather in the garden share honest letters. This is the original content seen by the end user. But when an agent reads this in the HTML, it's read obviously garbage with some words. So what the rendering, the font manager or the font renderer, I'm sure I'm not using the right word, when it sort of reads the raw HTML words, it essentially has a giant mapping where it knows, oh, the tunnel doesn't mean tunnel, it means something else. And it renders a different word on the fly, which is morning in this case.
Yeah, it's typically a font is glyph representations of what you're rendering, and they get combined. And I assume these, for certain words, get combined in a way that they're rendered as a different word than what you typically would actually want to render a letter in that font.
Yeah.
It's interesting.
I did a lot of work
I didn't
with
know
the
that
CJK languages.
Did that combination.
Yeah, because like if you think of Chinese, Japanese, Korean, it's a picture representation of it. Yeah.
So it's not like letters compose into words. Sometimes the letters independently compose into a word, which itself is a whatever the representation.
Yeah, exactly. So they probably have a glyph for those specific words that swaps it out.
Wow, that's very clever though.
Very clever. I can see companies paying for this. I mean, this is a good technology. This is good stuff.
It's Uno switch for Claude putting out gibberish to us.
Yeah, totally. And is that? I mean, I don't understand. Maybe you should switch to Claude a little bit here because you brought that up. Let's talk about this. The Claude's the response quality, the way it phrases things has drastically gone bad. I don't understand any of this crap anymore.
I've went away from using it. It's so bad. Like
yeah.
I tried the simplified technical English and I tried a bunch of different things and I can't work with it anymore. So it's just been.
What do you attribute? The one attribution I saw read was, which sort of makes sense, that they're not dogfooding themselves. Obviously, internally, Anthropic employees probably using Mythos or Fable because they access a better model, right? They don't have restriction. So Opus 5 is probably not used internally. We mere mortals are using them. That could be one reason that garbage is such a garbage product.
Yeah.
Another thing is, I feel
that thing I think that you're referring to, they said that 4.5 was Opus 4.5 was the last one that they had dogfooded, which is why it was so good. And but ever since then, they've been using Mythos instead of these other models, and that's why they're not as good. I think I didn't actually read that. I heard that from a coworker about.
I can see that happening totally. But is there any other technical reason why it's gone garbage? Is that they have changed training? Have you heard about any of this stuff? Because the language has drastically moved. Something is influencing it.
I thought it was interesting that they put in the ability to specify a concise output, like because the model is not trained well enough. You have to tell it how to concisely output.
Yeah.
I don't know. It's in their favor as well for it to be very verbose if you're paying per output token.
More. Yeah.
I don't think that's what's happening, but that's definitely a side effect of
No, but that's a short-sighted. I don't know if that's the intention. Feels very short-sighted, right? I think ultimately, while we're all token sensitive, we're also ultimately going to decide by outcome. So many a times I've paid out of my, I paid for the bigger models because my outcomes were satisfactory. And even if it meant it was like, doing nonsense. But what is really difficult right now is it's unreadable to that point of I'm not able to comprehend what's happening. I mean, even if you attribute it to the fact that they want to make it detectable that this is AI generated and whatnot, like fine, but not at the cost of comprehension. So that's probably the, I don't know.
There's a book related to this. This is what AGI feels like. You stop the superintelligence by Nick Bostrom.
Oh, nice.
When the model gets too smart, you stop understanding and spend more time trying to figure out what it's doing. And that's kind of how I felt. I kept having to ask it to explain. And it would start abstracting terms that don't actually mean that the thing. Like if you press it, it's like, oh yeah, that doesn't make sense. I called that a widget, like because it really should use the actual term, but it starts abstracting abstractions on top of extractions, and that's why you get like grains and seams and load bearing. You get abstract language, you don't get concrete language. And that's been the biggest thing for me, because then I have to I don't want to make it dumb it down, so I would like use Socratic method and interrogate it versus like saying dumb it down for me, because it also wants to be super deep and technical and have these conversations the way it was trained. But I got fed up with it. And Codex was working so well that I started moving everything over to there.
Kudos to OpenAI, man. It's turning back. I feel like they're turning back. They're finally getting around.
I will say that this is a cyclical thing, and around October, November, that Anthropic will be back, even though I've turned away from them now. This is every fall they come back, so hopefully they'll have something.
Is that happened before? Is that going to be before pre-IPO? Okay. Sorry, go ahead.
Yeah, I mean, I remember switching out of Anthropic when they had this API issue for a brief period of time. It was unusable, at least out of India. The timeouts were terrible. Like
now it's terrible though. Actually, it's off the charts. It's crazy.
Yeah, again, they came back from it. So Rob has a point, like, this cyclical nature to their, being, but yeah.
So let's talk about you explaining something with Claude now, even though we are not a big fan of them anymore. What is this dynamic workflow?
Okay, so I kind of came across this very recently, and let me just share my screen. So a dynamic workflow is something that, okay, first of all, how do you invoke it? Is my screen visible?
Yes.
Yeah, so the way you invoke dynamic workflow is largely simply just say use workflow tool or use dynamic workflow and explain what you want to do, right? In my case, what I have done is I wanted to, I'm tuning my test-driven development skill. And in order to tune my skill, like I kind of wanted to say, hey, these are my boundaries and I want to test a few things and this is my workflow. Let me just pull up one thing so that I just talk about it in one shot. Okay. So this is an MJS file, which essentially encodes my iteration for tuning the test-driven development skill. So basically, let's say I have like a few parameters by which I judge whether the skill is working well. For example, is it doing vertical slicing of the problem statement versus writing all tests first and then writing all the code later? Then is it actually doing strong assertions versus weak assertions, which I can find out by mutation testing? Then I also look at the overall duplication and run a JCPD check or something like that. So I wanted to do all of that, but almost like say, hey, I have a bunch of rules which I'm using, but I don't know whether it's overly complicating my TDD skill. So I'll keep that in a bank and say, hey, pull each of those rules from there, insert it into the loop, into the skill, feed it to an unsuspecting agent. This is the skill and you have to solve this problem. And then have someone else judge like whether this is actually following the rules that I gave. And I wanted to do this in 3-4 iterations and things like that. And so basically that whole thing is encoded as an MJS file, a module.js file by a Claude. It's writes it down as a code. And then eventually it actually runs it. Like, for example, initially I did the progressive disclosure of the skill. Like, I didn't want it to have like a large skill file eating my context. So that I did. Then I did the refinement of the skill, where the iterations, there's a nice little UI that Claude itself shows when you do /workflows. It represents the MJS file itself in this format. And here's where you can monitor the progress. Again, this is a long running task. This is again very related to what we saw earlier, right? You put it in a dynamic workflow, you leave it alone for a few hours or maybe even few days if you wish. And if you have that kind of money, so you can just like leave it alone. And you have this nice little interface to go and monitor it. It's fairly rich. You can even look at it from your mobile if you have Claude connected it there. And it'll keep telling you like what's going on in each of these cases, and eventually comes back like, this is the one which I think is just interesting. Earlier I used to do this through Ralph a little. But again, coming up with a good prompt for Ralph is almost like very tricky. But dynamic workflows, I just did like one paragraph explanation as to what problem statement I have. And I had like Opus construct the workflow. And then largely the work was done by, you can see, right, in this case, Sonnet was framing the problem statement, handing off it to Heiko to do the actual coding. And Opus would only be the judge of what is the level the skill has actually helped. So basically, I used dynamic workflow as a way to tune my skill to my code base and to my models before I used it on my code base, sort of, rather than just generically using a skill as is.
So
again, I don't know. This is a
dynamic bit here is that you don't sort of explain the middle. It figures out what the middle steps looks like, right? That makes it dynamic.
Dynamic meaning it is multi-agent, and I think what it also means is like, it kind of it's self-managed. It runs all by itself. I don't really have to do anything. In my machine, it's running off of like the shell sandbox, so I don't really have to keep like bothering with permissions. So it's almost like self-YOLO on the shell level, and it does the job and comes back like, it's even, I'm showing you a very silly use case probably, but if you have a more deeper thing to solve, like a large problem, this is more reasonable, I guess. I just had one example to show, but maybe Rob, if you have something to add there on this, please do.
Yeah, I love dynamic workflows. Like, I've been using it since it came out, especially if you have like something big that you want to accomplish and you don't have to write all the details of the workflow. It will generate it for you, generate code. And that's why this is RLM like. I know we've said it multiple times on this episode. But yeah, so what you have up, Eric Meyer was like wondering what the AST for this structure was, the code that it generates for dynamic workflow. So I had Claude analyze itself, decompile its own binary and figure out what the AST for what is actually generated for dynamic workflows, so that you could validate the workflow before you execute it. This goes back to the thing that I said was interesting to me, which is validating tool calls before you make them. This is, using an AST to validate the output of the model. You can quickly figure out whether it's safe or not. But yeah, I love dynamic workflows there.
So you actually used a workflow to review the workflow itself, right? Is that right? Am I getting it right?
Correct. Yeah.
Okay. Nice.
I was like, decompile yourself, and then
that's interesting.
And then generate a dynamic workflow and use this AST to validate it, and just keep stacking meta stuff on meta stuff.
So that's some of the
what I found. Sorry, go ahead, Neil.
Yeah. No, go ahead, please. Go ahead.
I was just curious, like what I found interesting about dynamic workflow in Claude especially is that earlier agent teams is something that I use quite a lot because it could fan out work for larger things of larger volumes of work. But with agent team, I never had control in terms of how that iteration would happen. With the MJS, I think I already know I can review what's gonna happen, check it out, and then like let it go, right? Like that level of control is what I personally like about the dynamic workflow. Again, I don't know what's dynamic, the name of it, so it's just like as an orchestration, it's really
the
nice.
dynamic piece is like you're generating code to do it.
Yeah.
As you
and
go,
then it's,
fair enough.
and then
Yeah.
it's deterministic once it's generated. So it's deterministic-ish, which makes it dynamic.
So
fair enough.
So another way to do that would be is you switch to plan mode and plan the thing, and once you approve the plan, it implements. Like give me an example where, if you can, when should I reach out for, hey, this is a good for dynamic workflows?
For me, it's like whenever I need to do something big that is like it's like a lot of work, and
Okay.
it can write code to do it, and multiple tasks running in parallel, and you don't actually have to determine the workflow. It will help. You can work with it to like determine the workflow, but like once it's set, it can just go off and do it. If you just say ultra code, it will use this. It's just a way to do a lot of work and spend a bunch of tokens to get that work done. Think of anytime you have a workflow, that's when you would use it.
Okay. So
I had
making
like
changes
one
across
use
multiple.
case. Yeah, I had one use case like I had to switch out like a really old DLL in a project, and it was very pervasive across the place. Like, and it was not very easy to figure out until you knocked off the DLL to see like where all the dependencies like would fire off. I hardly had to write like 3 lines to say, hey, the way you can figure out if this DLL is used here or not. It's like proper DLL health situation, right? I was like dealing with. So I just said like knock it off, see what happens. Again, keep going through the code base and like fix the header references. And it did it. Like it is like really old code base. I have no idea. I don't understand C or C++, and kind of did it over like 6 hours, I guess. But then, yeah, that's the kind of work which I would give it, because a plan mode can never really, like I can give it the plan, but the plan really doesn't pervasively or
you don't know what you don't know, right? So
yeah. And I think what Rob mentioned about that certain amount of deterministicness about it is good, I guess. So
yeah.
Like in your example, each DLL could have its own task where it goes off, and one task is looking at that DLL.
Correct.
And that information rolls up, and then there's another task once all of those finish that understands the dependencies based on what it found in each one, and that's the workflow. It's like I can go wide, I can fan out, and then fan back in, and then summarize what, answer the question. Like that's the type of stuff that you're doing. Is it's when you're a workflow, or like what you typically think, where you're fanning in, fanning out, parallel processing, summarization.
So
it's almost like you have the core problem, you can frame it in 3-4 sentences, but the actual work is very large, and probably it's a good use case.
Yeah. Okay. So one of the things that I saw a recent YouTube video. I should link it somewhere. It's not handy to me. I was exploring, like I said, I was exploring inference engineering this week. I was studying old school studying. Maybe we'll cover at some point. But one of the things that came out is that, how we are chasing for latency so much these days. And I think most of this are driven by cursors and coding agents, because we need to get the fucking thing right as soon as possible. But the workflows and other things are becoming, that makes a demand for a stronger hardware, faster processing, all that. Just increasing the cost, right? And here you talked about it, the tokens are sort of expensive. In the workflow mode also, on the other hand, there is a potential issue of it might burn through lots of tokens as it's figuring things out, right? I think that's okay. I think the trade-offs here is that we can run workflow on maybe when it's not scalable, maybe middle of the night. You know what I mean? Like batching the work in such a way, maybe with latency doesn't matter. It doesn't matter if it takes a couple of hours. I'm going to bed anyway. I think there is a tremendous thing that's happening here will open up. I think we're going to see lots of models and cheaper token prices for exactly this kind of work demand. I don't need seconds of response here. Just run in the background, right? I don't care.
Yeah.
Just send me tomorrow morning what the update.
You can run them all on Luna, super cheap.
Yeah. So
I even saw someone, I think Herdr itself, someone had a plugin. I don't recollect the name. You can use like really cheap routers. And if you run out of tokens, it will just wait for the window to reopen again. And then like again resume from where it left off. And so you just leave it alone. So like if you hit the 3-hour window and you have to wait 3 hours again, the harness will do it for you, or the agent multiplexer will do it for you. So you don't really care.
That's the smart bash loop where it actually waits.
That's pretty cool. All right, so one last story I want to cover before I let you guys go, which is which made lots of buzz this week or last week. It came out. I know I mentioned Cursor. Cursor actually was one of the things that pushed for latency because they needed faster. But they released something called Origin as a new code hosting. Here we thought GitHub is all we need. Apparently, Git have some issues and they're building up. I know, Rob, maybe you want to take a stab at it and explain what problem Origin is solving. I know they're fundamentally building something that GitHub was not designed for. GitHub was designed for us, humans. But Origin is for agentic scale, right?
Yeah. I mean,
so what?
Essentially, it's in how that the underlying Git works. It packages up changes and sends them over essentially as a zipped file. And
pack files, right? Pack files or something.
Pack files, yes. And like that's the root cause of the problem is that you have these changes, and how that works with the distributed system, because Git was meant to work locally, but not to be centrally managed. So at scale, you run into all these issues, and it took GitHub several years to get there. And the method that they were using is from 2013, and Cursor essentially said, well, we're going to use current distributed system technology, algorithms, whatever, to improve upon this.
Which is S3 buckets.
Yeah, well, and that's the interesting thing is that is the hot topic right now on X, is like write-ahead logs, which is what it's using. Which you can do with SQLite. CellD is also doing durable objects with SQLite, and
but S3 gives them the
storage is S3.
S3 gives them the centralized sort of lookup, though, right?
Correct, and that so like the fact that S3 exists and it is like the most reliable service that has ever been created in the world. The fact that you can rely on that is why you can build services like this. So if S3 did not scale, this whole thing would not work. You would have downtime and like corruption, and you wouldn't be able to ensure that what you're storing, the data that you're storing underneath, is correct. And that's like a huge problem. Not only that it replicates correctly, but that it didn't get corrupted on disk, and all these other things that can happen with infrastructure. But what they're essentially doing is a write-ahead log, and using S3 to store that write-ahead log, and it's just passing metadata in between. And the same as what GitHub is doing, they do actually keep a GitHub repository on disk for you. But there's a hash.
And it have to. It's not GitHub's. Just to be fair, it's not GitHub's. It's a Git's protocol. Git protocol mandates to have this. This diagram is kind of showing that when you clone or you ask for pull, it have to walk through that the file, because it's a random access to the blobs to get the sections of the file. It has to be on the disk. Just FYI.
Yeah, so that's part of Git, but in terms of like how GitHub had set it up, like you have to, it's the Git plus how GitHub set it up is you have to have like the full repository so that it has an accurate representation.
And redundancy,
one of the
right?
things that cursor is, and redundancy, yes, cursor is doing differently. The fact that S3 is your write-ahead log and is stored, it hashes the candidates of nodes that this should be deployed on, the nodes that have the file system. And it just picks the first one. And so that is always your primary. And then it has some replicas depending on whether it's like a small repo or a mono repo. It can use the other ones. And so it's always guaranteed to be fast when things are going well, but correct when things are running slowly, because essentially if their infrastructure is going wrong, they can recreate the repo from the write-ahead log that's in S3 and stand up a new node if other ones are failing. So it might be slower, but it will be correct if they're having infrastructure problems. So it's, you get the best of both worlds, I guess, is everything's going well, it's fast, but then if things are not going well and it is slow, but it is correct.
Yes. And this diagram is a good one, what Rob is talking about. This is sort of your bottleneck, their spoke system that you use. A replica sort of makes sense, right? Last thing you want is you uploaded your repository, it sits in a disk, and this does go bad. I mean, it happens all the time. So that's why
the key thing with that too is it doesn't scale. So as you add replicas that you have to maintain, it just gets worse and worse.
And this is a good diagram for that too. Some replicas are fast, some slow, but the way the spokes is designed, that it has to be consistent all the time. So it slows. So your slowest unit in the network. It's a classic distributed computing problem here. So S3 solves a bunch of these issues. Another thing, you have to talk about what makes this more struggling, because, and GitHub acknowledged that too, with AI agents now cloning repository, creating smaller repo, lots of them together. This treatment gets for all the repositories. So your Linux open kernel to your toy repository that your agent created, all going through the same process. So number of repository getting increased means too much pressure on this. So the scale is actually making this problem even worse for them. So this is a fascinating article. If you haven't read, I will definitely encourage you to do that. Not only you understand how the whole Git works, the history behind it, how not only this GitHub, any Git hosting sort of provider I've read that sort of uses similar model for consistency. And S3 approach sort of resolves that.
I'll frame it a different way. You should read this because you should be interested in good engineering and like what's working and what doesn't, and learning from the past. And when people say that software development is done, but software engineering is alive and well, this is what they mean. Reading stuff like this and understanding how a distributed system works at scale and what engineering it takes, like that is why you should go read it. This is an excellent article.
Yeah, that's well put. In fact, this is a classic case of amplification, right? A problem which was not earlier as big an issue has now been amplified because of the involvement of agents, which means gotta get our hands dirty and solve that problem now.
The hashing algorithm they use to determine which nodes I had never heard of, but then I started looking into that as well and going deeper. But that's the type of thing you have to do to just continually become a better engineer.
All right, that's a good note to end this podcast then. All right, so anything else you guys want to cover, or should we wrap it up?
All good.
Okay, all right, cool. Thank you so much, guys. Thanks for being here. I hope you enjoyed. Any questions you have, you can also hit us. I don't know how you can hit us on our YouTube. I'll provide more information here. We'll get more organized on this. But thank you so much, guys, for your time.